Okay, in this video, we are going to learn how to solve the nonlinear programming model by using the Excel solver. Here's the situation. Perman and Brothers, an investment company, they want to invest a given amount of the money in 3 stocks. It is called IBC, NMC, and NBS. From the past data, the mean and standard deviation of annual returns have been estimated here as follows. The correlations among the annual returns on the stocks are also computed. And in this situation, the company, they want to find the minimum variance portfolio that give us the least 12% of annual return. We define 3 variables in this model. The P1 is the proportion of the funds invested in first stock, IBC. And the P2 is the proportion of the funds invested in the second stock, NMC. And the P3 is the proportion of funds invested in the NBS. We've discussed that the variance of my portfolio is expressed as shown in here as in the objective function. Here, the sigma is the standard deviations of the stocks, and R represents the correlation matrix of this problem. There are some constraints in this model too. The first, P1 plus P2 plus P3 is equal to 100%, which means the sum of proportion should be equal to 100% or 1. And also P1 times expected value of IBC plus P2 times expected value of NMC plus P3 times expected value of NBS has to be greater than equal to 12%, which means that we want my expected return to be at least 12%. Finally, my decision variables P1, P2, P3 are all non-negative. Okay, if you take a look at the spreadsheet on the left, then you will see that the data is already entered in the spreadsheet. At the top, we have mean return and standard deviation of returns of 3 stocks. And the correlation matrix is given here. There are cells for my decision variable P1, P2, P3. My first constraint is that the sum of proportion is equal to 1. Therefore, we enter the sum of my 3 decision variables has to be equal to 100%. The second constraint is that expected return is least 12%. So we're going to use the sum product to express this constraint. The sum product, my first array, my decision variable from B15 to D15, and my second array is in the B5 to D5. Okay. This has to be greater than equal to 0.12 or 12%. The next array is kind of intermediate step before we compute the variance of portfolio. So here I like to express sigma times p. Okay, so we can type p1 times standard deviation of my first stock as the first array of this intermediate calculation, and then second element of this array is P2 times standard deviation of my second stock, and then my last element is P3 times standard deviation of NBS. Okay. Once you enter like this, and then next I like to multiply two metrics. The sigma time p times sigma standard deviation is the one of the metrics, and I do have correlation matrix R. So using the M mul, I am going to express this matrix multiplications. First, I am going to use M mul with the first matrix and the second matrix. Okay, so here in the B27, I typed M mul, and my first array, which I already compute, and my second array is the matrix above, and hit enter. Once you hit enter, what you need to do next is choose the range of the result of the matrix of these multiplications. So I choose from B27 to D27, and then enter the F2, and then enter the Control Shift and enter at the same time. Okay. Then you will see that the numbers are automatically computed and entered in the results, the cells. Okay. Once you did that, I am going to use sum product to complete these computations. Okay. Sum product of my first array and the p times standard deviation. That will give us the variance of my portfolio. Now, we go to the Data tab and choose Solver. We set my objective cell as the B29. This has to be minimized. I choose the min and choose the array for my decision variable from B15 to D15 and add two constraints. My first constraint is here. My total investment has to be equal to total that I have. Add one more constraint. My left hand side, this is my expected return, has to be least larger than or greater than or equal to 12%. And hit OK. And make sure that you check this checkbox because my decision variables are all non-negative. And choose the solver non-linear and hit on OK. Solve. Then they said the solution has been found, and hit on OK. Then you can see my optimal solution or optimal strategies in this problem is to invest the 50% of my money to the first stock, and another 50% of my money has to be invested in the third stock. Okay. So please try to do yourself, and then if you have any other questions, come and bring your question to me.